Okay, so I don't know if it's explicitly covered in the notes, but when you see like a complex number like this with a bar across the top, this literally it's just the math notation for the conjugate. Hold on, I have to learn how to spell conjugate. So what we're going to do is just say it's kind of weird that we even need a notation because to write the conjugate, it would just be to change this sign. So it's going to be 6 plus 11i times 6 minus 11i. And we'll just FOIL. So when I do the first term, I get 6 times 6, I get 36. Outer, I get negative 66i. Inner, I get positive 66i. And that's why we multiply by conjugates, is that the imaginary part of the complex number will now kind of go away. And then last is going to be negative, because I have a negative times a positive, 121 I squared. And now the only real step, these two are going to cross out. And then I have an I squared here. Whenever you see an I squared, that just becomes negative 1, which will ultimately make this thing positive. So I'm left with 36 plus 121, which gives me a final answer of 157. If you know you're multiplying some complex number by its conjugate, there's kind of a shortcut. You might start to notice a pattern when you do these. Notice I ended up with 36 plus 121 from multiplying 6 plus 11i times 6 minus 11i. You can really just say, okay, whenever I'm multiplying a complex number by its conjugate, I'm just going to add the squares of these two numbers. It's kind of a quick shortcut. Maybe don't take that shortcut, but use it to kind of just double check your answer real briefly. 157 is just 36 plus 121.